Okay, thank you very much. Thank you for having me here. Thank you for the organisers for inviting me. I am from New Zealand, so hopefully you guys can understand my accent. Just a quick conflict of interest. Arthrimid is manufactured in Denmark by Contura, a UK-owned company. It's registered and distributed in New Zealand by Innovative Medical Solutions, and I am a shareholder and director of Innovative Medical Solutions. It was my team and I that ran the regulatory profile on this product to get it registered. So I'm going to talk quickly about the histologic and cytologic changes in normal equine joints after injection with 2.5% injectable polyacrylamide hydrogel or 2.5 iPAAG. And just acknowledgement to my other co-authors, Dr. Lita Clifford, Dr. Alan Julian, a pathologist at IDEX Laboratories, Janet Patterson-Kane at Horseworks in the US, a board-certified pathologist, and Mark Kuhner from Terlouche Veterinary Hospital in Germany, who's worked with this product for longer than I have. So the study objective at the time, we did this work back in sort of 2015, 2016, and it was very much to characterise the nature of the synovial integration process. As I said, it was part of developing a safety profile for regulators in Australia and New Zealand. The talk yesterday was interesting. We do not have a medical device category in veterinary medicine in New Zealand or Australia. This went through as a veterinary medicine. So it went through the full 5 dossier program. And the regulators were asking some quite cool questions really, because they wanted to know, this was a new active, it was going into the joint of animals, so we really wanted to know what was happening after we inject the gel, where does it end up, and how does the body respond to that, to the gel. And I'm sort of presenting this paper now at a regenerative medicine conference, probably 7 or 8 years later, I guess because of COVID, but also because the findings, we've sort of reinterpreted our earlier findings, given the recent advances in understanding the role of synovial tissue macrophages, and I'll sort of review that in the last slide, and also sort of to identify those research opportunities that we have now coming up as a result. So our materials and methods, we had 10 horses, they were all thoroughbreds, they were resting or retired at a local farm. None of them had clinical signs of OA, they were aged 3 to 5 years, there were 5 geldings and 5 mares. Because we're doing a target animal safety, we had multiple dosing, so we did 2 mils, which was the recommended dose at the time, so 50 milligrams or up to 100 milligrams in one joint. We did multiple joints on multiple horses. And we used fetlocks, front fetlocks, hind fetlocks, metacarpal, tarsophalangeals, and the middle carpal joint. We collected samples at either 14 days, 42 days. We took one horse out to 90 days because the regulator had a specific question at that time. Where we could, we used untreated contralateral limbs as our controls, and we measured for outcomes with clinical exam, lameness, effusion, reaction, deflection. We took pre- and post-treatment synoviocentesis samples, and we did some post-mortem, and we took samples from that through to histology and scanning electron microscopy. And we did some statistical analysis with a GenStat 23. So our results, the first really interesting thing, there was no adverse events at any time point in our study. This is pretty consistent now across multiple published studies with this product. It appears to be very safe. Published study adverse events are about 0.004%. My own clinical experience and the vets that I communicate with globally was sort of 1 in 2 or 3,000, sort of 0.0005. So gross post-mortem, again, this was a slide with from Mark Kuhner in Germany. He added some methylene blue to the gel. And the key here is there's no free gel in the synovial space. This is 2 weeks after injection. So the gel all gets integrated into the subsynovium. It's not floating around in the synovial cavity, as you can see in here, but it's all sitting in that subsynovium. And so this product does not work as a visco supplement. I know that you have a 4% product available in the US market, promotes that fact, but I do disagree with that. Our synoviocentesis, the most important thing here, we looked at total nucleated counts, red blood cells, total protein, albumin, globulins, mononuclear cells, and our differentials with lymphocytes, neutrophils. And the key there, again, all results laid within at all times were in normal laboratory limits. The only subtle thing we saw was a slight increase in total nucleated cell count compared to controls, and this was predominantly mononuclear cells. So the key thing there we learned was this product induces a mild monocytosis in the synovial fluid out to around 14 days, and it's normalised again by 42 days, and certainly out by 90 days it's back to normal. The histology, this is a normal control joint, and I just sort of, the synovial cavity sitting in here, the intimal layer, and again, just in this box here, you'll see the sort of slightly zoomed in. I'll just draw your attention to this slide and look at those cells there, sort of typically 2 to 3 cells deep on the synovial intima. Those are your synoviocytes producing synovial fluid. Beneath this, we have the subintimal layer, which is typically fibrous tissue and blood vessels, and underneath that, we have our joint capsule. So what happens in the treated joints, the treated synovium, the gel is integrated into that superficial subintima. Again, and this is indicated on these slides, is that sort of blue haze in the subintima. Both of these slides were at 14 days. And no gel overlying the synovium. So again, it's all fully integrated by 14 days, which was consistent with our gross post-mortem. If we just zoom in a little bit there on that subintima, we'll see that there's an inflammatory response, and that's mostly macrophage driven. So again, it's these macrophages coming in response to the gel. The important thing, we demonstrated that there was no granulomas, there's no neutrophils, and there's no fibrosis. So this isn't a fibrotic reaction, this is an inflammatory reaction by definition. And those macrophages, what the pathologist described as a frustrated attempt to phagocytose the gel. Again, they don't succeed in phagocytosing it. Again, this is a subtle difference with a 4% gel. The paper by Scott McClure and his team demonstrated that gel broke down and was phagocytosed, and this one isn't. Again, if we look in more detail at the intima, there was significant intimal hyperplasia, so an increase in the number of type A synoviocytes. So again, if we just look at that zoom in image there of the intima and compare that to the normal slide that we showed before, you've now got sort of 5 or 6 cells thick. If we look at the villus structure, so villus hypertrophy, a significant villus hypertrophy in response to the gel. Okay, so hypertrophy is the increase in size. Again, looking here on the left, that's a normal joint, and the one on the right is obviously the gel injected. So you've got those synovial villi are bulked out by the gel, and the macrophage infiltration in response to the gel. Quickly run through the scanning electron microscope images. The top left there is the normal raw gel, and you see this lovely sort of uniform, porous, three-dimensional scaffold structure. And that's very much the company report, their technology, and when they make this gel, it's the ILX cross-linking that makes it very uniform. They control the conditions in which the gel is laid down, and that gives you that very uniform, porous structure, and the product's very stable. It also affects its viscoelastic properties and its biocompatibility that Meg was talking about yesterday. So I guess what in conclusion, and where we got to, the Aziz Nibar study in 6 goats back in 2017 suggested a purely mechanical mode of action. And that doesn't really fit with the clinical benefits that we see and my colleagues see. I'm a practitioner, and it didn't really explain it all. What we do see is significant hyperplasia and hypertrophy of the intima and subintima, and this is predominantly macrophage driven, and this is described as a simple foreign body response to foreign material. That's well documented in human medicine where devices are very commonly used. So I guess you're asking, why is this guy from New Zealand standing up at a regenerative medicine conference telling me injecting gel into a joint that causes inflammation is a good thing? It's certainly something I ask myself as well. There's irrefutable proof now that this product is highly efficacious. Multiple published studies across multiple equine populations, across multiple countries, all have an efficacy of around 65 to 80%. And what I'm excited about and where we need to take the research on this product is looking at more detail at these macrophages. And these are two papers that have come out recently. This is Manaram and the team at Virginia Tech. This came out in 2020, looking at the role of synovial or macrophage activation in the synovium of healthy and osteoarthritic joints, and this sort of concept of pro-resolving macrophages. And then this paper by Karowski, Stalaska and Alvarini, which was the Arthritis Centre in Glasgow, looking at the synovial tissue macrophages and joint homeostasis and rheumatoid arthritis and disease remission, and identifying the different phenotypes of synovial tissue macrophages. There's not just one, there's a multitude of them, about 9 different phenotypes, in particular these MERTK macrophages, which can be pro-resolving and disease-modifying. And this is just a note to Steph Dakin and her team at Oxford University are also studying tissue signalling in human medicine and soft tissue injuries. And I think this is where the research needs to go. And I know that Contura have teamed up with Colorado State and Laurie Goodridge and her team, and Katie's here as well, to look at this role of these pro-resolving macrophages, identifying or quantifying the changes in synovial fluid quality, because we tried to do that, but we weren't very successful just looking at cytokines. We need to look at some other things. And we can do that by looking at synovial biopsies serially through the carpal chip model and looking at that gene regulation. So thank you very much.
Thank you very much. Any questions?
I may have missed it, but what was your hypothesis for the function of this polyacrylamide to begin with? Why did you decide to use that or not any other polymer?
It wasn't really, so I'm a clinician. The manufacturers of this product, they looked at when they developed the product, they looked at the biocompatibility and came up with the 2.5%. The higher concentrations of these gels seem to be less biocompatible, if that answers your question.
Biocompatibility is one thing, but anti-arthritic function is another. So that's I guess what I'm asking. What anti-arthritic properties does this polymer has that drive your study to begin with?
Yeah, we were going through the regulatory pathway. That's what drove our study to do this. We wanted to look for the answers as to what was happening when you injected this gel into the joint of an animal, what was happening. There were some earlier published papers out of Copenhagen University, but we need to prove it. We need to show it locally for our regulators, and they also had specific questions around taking it out to 90 days.
Okay, I would like, if I understood well, you would like to identify those macrophages a bit more in detail now, what you want to do. Yep. Okay, so I wanted to ask, what about, I'm not familiar very well with equine macrophages, if there are enough data about markers, about different subpopulations of macrophages, if you are able to do it based on the literature, and what are these? What are the most? If they cover with I don't know these which we know from human.
So there's some, Steph Dakin, she used to work at the Royal College with Roger Smith, and she's got some markers there, and Manaram and their team at Virginia Tech, and I know this team at CSU have looked into that. There's not a lot of published data on it, and it's so recent. The paper there from Glasgow just came out last year, but we have got some things to work on there.
All right, thank you so much.
You're welcome.